So in chapter 3, we are basically going to be talking the entire chapter about the concepts of parallel lines and perpendicular lines. But this first section is not about parallel or perpendicular. This first section is just talking about any two lines. Any two lines that you might have. They do not have to be parallel. They do not have to be perpendicular. If you take two lines and you intersect them with a third line, this third line is called a transversal. So the first thing you're going to see in your notes, let's switch to the other side. I'm going to do it first. So if you'll switch to the other side, I'm going to fast forward here, come back to this. We'll come back to it. Okay, let's start with this side. So are you guys on this side with me where it says transversal corresponding? Everybody on the same side with me? Okay, I want to start with this part first because this is the part that you probably did see back in 7th or 8th grade at some point, depending on who you had as a teacher. These are frameworks that should have been taught to you, okay? Again, it may be that you forgot all about it, and this is, you're like, oh, I think I remember those words, but it's okay if you didn't. We're going to go over it like you've never seen it. This line right here is called a transversal. A transversal is a line that intersects two coplanar lines at two different points. So if you look at my picture, this line is intersecting two other lines at two different points. So we call this the transversal. You're going to be identifying what is a transversal in this lesson, okay? When a transversal intersects two other lines, and they do not have to be parallel, just any two lines, it's going to create 8 angles. Does everybody see 8 angles that are formed? Okay, those 8 angles have some relationships with each other, and they have specific names. And there are 5 types of angles that are formed. If you look at the notes here, you're going to see 1, 2, 3, 4, and then for some reason, this book skips the 5th one. I have no idea why, but we're going to add it to our notes in every section. So there is a 5th kind of angle that is formed if you'll add number 5 at the bottom. I'm going to write it way up here at the top because those in the back can't see very good if it's way down here. So it is called same side exterior. Same side exterior angles. Same side exterior angles. So there are 5 kinds of angles that are formed. There are 8 different angles in the picture, but 5 types of angles. And so what you're going to have to do in this part of the lesson is figure out which angles are these 5 types, and you're just going to be picking them out. This is essential for being able to be successful in all the rest of the sections in Chapter 3. If you can't identify the angles correctly, you will not be able to work anything else. So this is huge, okay? So the first kind of angle is the corresponding angles. Corresponding angles are 2 angles that lie on the same side of the transversal. So first of all, let's look at my picture up here on the board. Which angles are on the same side? 1, 3, 5, and 7, okay? Or on the other side would be 2, 4, 6, 8. So when they're talking about same side, they mean either on the left or on the right if your transversal is drawn like this. So they're on the same side of the transversal, but they're also on the same side of the other 2 lines. So 1, 3, 5, and 7 are to the left. They're on the same side of the transversal. But which 2 angles are on the same side of the other 2 lines? So 3 is below this line. So what other angle is below this line? 3 and 7. Okay, we're a little weak on that. Let's try again. So notice with me, these are all on the left. Now pick 2 angles that are in the same location with respect to these lines. So 3 is below and 7 is below. Do you see how they're in the same location? When I think of corresponding, I think same location. Same location. That's the big idea. They got to be in the same spot with respect to the transversal and the lines. So 3 and 7 would be corresponding. What other angles would be corresponding? Okay, 4 and 8 would be corresponding. I'm going to write that over here. Angle 4 and angle 8. What other angles? 2 and 6. Those are both above the lines and to the right of the transversal. What else? 5 and 1, and that's the one that they listed, 1 and 5. The other pair that we listed first was angle 3 and angle 7. So notice there are 4 different pairs of corresponding angles. They're in the same location. Think same place with respect to transversal and same place with respect to the other 2 lines. Any questions about corresponding? Okay, how many of you have heard and seen corresponding angles before? All right, so if you are saying yes, some of you may not remember, but you should have talked about that back in the other grades. Okay, the second kind of angles that are formed are called alternate interior angles. Alternate interior. By alternate, they mean that they lie on opposite sides of the transversal. Opposite sides. So one's going to be on the left, one's going to be on the right. But not just opposite sides, they're also interior angles. And when they're talking about interior, look up here at this picture on the board. Interior means in between the 2 lines. So 3, 4, 5, and 6 are all interior. Exterior would be 1, 2, 7, and 8. They're outside the 2 lines. Okay? So we want the ones that are on opposite sides of the transversal, but interior. So they say that is 3 and 6. Or it could also be 4 and 5. Is everybody with Jackson there? Those are both on opposite sides of your transversal. One's on the left, one's on the right, and they're in between the 2 lines. Alternate interior. Okay, the next one is alternate exterior. Basically the same idea, that they have to be on the same, they have to be on the opposite sides of the transversal. But this time, since it's exterior, they have to be outside the lines. Okay, so if you look at the picture, which ones are on opposite sides of the transversal but outside the 2 lines? Heard 2 and 7 or 1 and 8. And so they say 1 and 8, and we'll add or angle 2 and angle 7. Okay. And then the same side interior angles. Notice the word, same side. So that means they're going to be on the same side of the transversal, but interior angles only. So same side interior. So if we look at the picture, which ones are on the same side of the transversal, but interior angles? 4 and 6, or they said 3 and 5. So angle 4 and angle 6. And then we're going to add in the one the book skips, which is the same side exterior angles. The definition is basically the same thing. They have to be on, they lie on the same side of the transversal. So they're going to lie on the same side of the transversal, but this time they're going to be outside the lines. Okay, so same side exterior. The name tells you exactly where they're at. They're on the same side of the transversal, but outside the 2 lines exterior. So what would be a pair of same side exterior? Not 1 and 2. Not 1 and 8. Same side of the transversal. So look at your transversal. Which angles are on the same side but outside the 2 lines? 1 and 7. So this would be angle 1 and angle 7, or 2 and 8. Angle 2 and angle 8. Any questions on the 5 different kinds of angles? Okay, we're going to practice real quick. So if you look at the next examples in your notes, they're going to ask you to pick out a pair of angles, and there's going to be multiple possible answers. Just like up here, there were multiple possible answers. So let's do these together. It says, give an example of each pair, starting with corresponding angles. Nathan, can you give me a pair of corresponding angles? Careful, 1 and 8 are both to the left of the transversal, but 1 is above the line and 8 is below the line. Correspondings have to be in the same location. Hold on, Jax. Say it again, Nathan. 1 and 5 is correct. Angle 1 and angle 5. And it just says give an example. Even though there's multiple options there, just pick one. So angle 1 and 5 would be corresponding. Remember, corresponding is the same position. They need to look like they're in the same position. Okay, alternate interior. Faith, can you give me a pair of alternate interior angles? Very good. Angle 4 and angle 6. Alternate exterior. Barrett, can you give me a pair of alternate exterior?
1 and 6.
Careful. 6 is an interior angle because it's in between the two lines. There you go. 1 and 7. Angle 1 and angle 7. Naomi, can you give me a pair of same side interior? Careful, 1 and 8 are exterior angles. They are outside the two lines. Interior angles have to be in between the two lines. 4 and 5, very good. Angle 4 and angle 5. And then we're going to go ahead and add part E here, even though it's not in the notes. And again, I'll put it up here where you guys can see it better. Add same side exterior. And let's go with Chris. Can you give me a pair of same side exterior angles? Careful, 1 and 7 are on opposite sides of the. There you go. Angles 1 and 8 are same side and exterior. So angle 1 and angle 8. Okay, I want you guys, you and your partner, to try the next 4 on the second example in your notes. So go ahead and try those. All right, let's see how you're doing. Dylan, can you give me a pair of corresponding angles? 5 and 7, very good. Tori, can you give me a pair of alternate interior angles? 2 and 7, very good. Jacob, can you give me a pair of alternate exterior angles?
Angle 1 and angle 8.
Good. Angle 1 and angle 8. And let's go with Reese. Can you give me a pair of same side interior angles? Very good. Angle 6 and angle 7. And they didn't ask you for same side exterior, but Sydney, could you give us a pair of same side exterior angles? Yes, correct. Angle 5 and angle 8, same side exterior. Anybody have different answers and they're not sure if they're right and want me to check what you have? Okay, let's look at the last kind of problem on this set of the notes, and then we'll look at the other side. So the last kind of example is not only going to ask you to name what kind of angle pairs you have, but it's going to ask you to determine which line is the transversal, because you're going to have the lines intersecting differently than what's in this picture. So every two lines is going to be intersected by another line, which means they could all be considered transversals. So they're going to ask you to determine which one is the transversal for your angle pair. And then there's a little helpful hint here that's not in your notes. So if you'll look up here and read this with me. To determine which line is the transversal, if you're struggling and you're not sure, locate the line that connects the angle's vertices. Okay, so look at the two angles, put a dot on each vertex, and then draw the line that connects those vertices. And that will tell you which line is the transversal. So for example, says again, make sure that you're doing both parts of the problem. Identify the transversal and classify each angle pair. So that means you're going to tell me which line is the transversal and then what kind of angles are they. So if you look at angles 1 and 3, first of all, let's identify the transversal. So put a dot where the angle's vertex is, and then put a dot where angle 3's vertex is. Which line connects those 2 points? Line L. So you would say the transversal is line L. And remember chapter 1 notation for naming a line. You put the word line and then the little letter out to the side. Okay, so that's the first part. Line L is the line that's going through those vertices, so it's the transversal. The next thing that you might need to do if you're struggling with these is cover up the other angles down here. Don't look at those. Look at only these angles that we're talking about and the lines and the transversal. What kind of angles are 1 and 3? It's not same side because they're not both interior and they're not both exterior. So they're corresponding. Corresponding are always on the same side, but it's going to have one interior and one exterior. So they're in the same position. Remember, corresponding is when they're in the same position. They're both below and to the left. So that's corresponding. So part B would be corresponding angles. You should, because it's saying for you to identify what kind of angles they are. You can just do that little angle symbol though. All right, 2 and 6. First of all, look at 2 and 6 and identify what is the transversal. Very good. Again, if you're not sure, draw that angle and find the vertex. Draw angle 6 and find its vertex. And the line that connects those two vertices is your transversal. So the answer should be line in. And now what kind of angles are 2 and 6? They're not corresponding. Alternate is correct. It's not exterior. Look at your two lines. Again, cover up 3 and 4 if you need to. But look at these two lines that are not the transversal. Do you see that 1, 2, 6, and 5 are in between those two lines? So that makes them interior, and then 2 and 6 are on opposite sides, so that makes them alternate. So it is alternate interior. Okay, let's try one more. Angles 4 and 6. So now we're looking at angle 4 and angle 6. First of all, what's the transversal? Line M. Again, if you're not sure, trace your angle, find the vertex. Trace angle 6, find its vertex. The line that goes through those 2 points is line M. Make sure you're putting the word line in front. Line M. So they are, very good, Chris. They are alternate because they're on opposite sides of your transversal. But if you look at the two other lines, they're not in between them. They are outside of them, so that makes them alternate exterior. Questions on this side of the notes? Pretty easy? Okay, this is probably the hardest part. The other ones is just picking out a pair of angles, okay? Let's go to the front of the notes. And this is going to be some of it you will have heard before. Some of it may be stuff you haven't heard before. I've hit my little arrow too many times, getting too impatient. Oh, now I lost it completely. Awesome. Well, the black thing went away though. Okay, so this side of the notes is talking about some different just vocabulary. You should know what parallel lines are. What do you know about parallel lines? They never intersect. That's what most students come to me with and saying they never intersect. But there is one problem when you get to geometry with that definition. Skew lines also never intersect. So just saying that they don't intersect is not a good enough definition anymore. Parallel lines not only don't intersect, but they have to be coplanar. What does it mean to be coplanar? Okay, they have to be on the same plane. If they're on the same plane and they don't intersect, we call them parallel. This is the symbol for parallel lines, and you can use that when you are naming lines parallel. So for example, notice that they named EG and FH parallel. When you look at the picture, EG and FH are in the front plane of this box, so they are coplanar, but they do not intersect. So we would say EG, this is going to go back to chapter 1 notation, and for those of you who struggled with naming things correctly, this is going to hurt you if you don't figure it out before this test. So EG has to have a line above it with arrows, FH, 2 letters, line above it with arrows, and then now we can use this little parallel symbol to say they're parallel. Okay? In the picture, they're telling you that they're parallel by using these little arrows. When you see these little arrows, if they have the same number of arrows, then those are the lines that are parallel. Notice down here, this is 2 arrows and 2 arrows. So that's telling you that FH is not parallel to AB, but FH is parallel to EG. So when you see those little arrows, that means the lines are parallel. So look for those arrows when you're trying to figure out, do you know for sure they're parallel? They may look parallel, but you don't know for sure unless the markings are there. Okay? So look for the ones that are marked. Perpendicular lines. What do you guys know about perpendicular without worrying about that definition? Okay, they cross how? Okay, they make a 90-degree angle. So not only do they cross because intersecting lines cross, but they cross to form a right angle. So when you see perpendicular, they're going to be lines that intersect at 90-degree angles. And this is our symbol for perpendicular. It's a capital upside down T. Okay, so again, you can use that symbol when you're naming lines perpendicular. So look in your picture. How are they going to denote that it's a 90-degree angle? Okay, the little square, the little box. So if you look in the picture, notice that we have a little box right here. We also have one up here. Don't assume that they're 90 degrees. Look for the markings when you're trying to answer the questions. So again, we could say EG is perpendicular to GH because these 2 lines form a right angle. Okay? Skew lines you probably have never heard of before. This is usually the new thing in this section. Skew lines are not coplanar. So they're not in the same plane. Okay? They're not on the front of the box, the back of the box, the top, the bottom, the left, the right. Be careful, there's also another plane that goes through this box that's not drawn. So when you think planes, you have to think of any plane that could exist. Would you agree that there are diagonal planes that could go through this box, for example, here? Okay, so would AB and GH be coplanar? I'm going to say that again. AB and GH, are they coplanar? Yes, because there is a diagonal plane that goes through the box. So are AB and GH parallel? Yes, because they do not intersect and they are coplanar. Okay, so be careful and think, could there be a plane? If there could be a plane, then they're coplanar. Okay, skew lines, however, are not coplanar and they do not intersect. So an example of a pair of skew lines that they give you are AB and EG. So notice one is in the back of the box and one's at the front of the box. So it would be like me holding my arms like this. Will my arms ever cross if they kept going forever? No, but they're not in the same plane, right? There's not a way to connect this arm to this arm with the same sheet of paper or the same flat surface. So these are considered skew. Can somebody give me a different pair of skew lines? FH and AE, very good. Those are not in the same plane and they would never intersect. Somebody else a different one. Jacob?
BG BW and GH.
BW and GH. Very good. One's in the back, one's in the front, and they're going different directions, so they'll never intersect. Is this making sense what skew lines are? There is a plane that connects A, E, F, and B. That's your top plane. So AE and BF would be parallel, not skew. AB and EF would be parallel, not skew. Okay. All right, parallel planes is basically what it says. They're going to be two planes that do not intersect. So planes that do not intersect. So in your box, that would be like the top and bottom would be parallel, or the left and right would be parallel, or the front and back would be parallel. Remember when you name a plane that you use 3 letters. So only 3. Even though there's 4 corner points, you don't pick all 4. You pick 3. And you must have the word plane in front. So when we name some planes here, we could say plane ABE. That would be this top plane. And the plane that it would be parallel to would be the bottom plane. And notice they said CDG, but there's no D in the picture. That's because this point W is labeled incorrectly. This should be a D. So CDG would be the bottom. Do you guys agree that those are parallel? Sure, Miss Ashley. All right, can you give me another pair of parallel planes in the picture? Go, Reese. Okay, but again, when you name a plane, how many letters? Just 3, so pick 3. HD, HFB, is that what you said? Okay, so HFB would be this right side over here. And when you name it, you would say plane HFB is parallel to, so we're using those parallel symbols, GEA. And again, we would put the word plane in front, plane GEA. Okay, first chapter 1 notation, super important for this chapter. Any questions on parallel planes? Okay, let's go through some examples pretty quickly. Maybe. Come on. It's because I clicked a button wrong a while ago, and so now it's going to be difficult. Okay, so let's look at this example. Careful with the wording, though. What are we looking for on every single one of these? A through C. Segments, segments, segments. So when you're naming, make sure you're putting a segment above it, not a line with arrows, okay? Super important. I'm going to be very picky about your chapter 1 notation. So part A, we need a pair of parallel segments. Again, when you look at the picture, look for those arrows. Those arrows should tell you which lines are parallel. Go ahead, Jackson. Okay, that is true, but they're not actually marked parallel in this picture. So I'm going to have us try to first make sure we're getting the ones that are guaranteed parallel. LQ and, sorry, I'm finding, and KP. Very good. So I could say LQ, line segment above it, use your parallel symbol, is parallel to KP. Okay, so to be confident that you have it correct, use the markings, okay? Because there are some problems where the pictures are drawn kind of weird and you think that they're parallel, but you don't know they're parallel. So I want you to use the markings to make your answers. Okay, skew segments. Remember, these are not in the same plane, but they don't intersect. Who can give me a pair of skew segments besides Jackson? Go, Jacob. NS and LQ. Be careful. Those are actually parallel. There is a plane that could go through this picture that would connect those, and so those would be parallel. And notice they're marked parallel as well. They've got the little parallel symbols on them. So NS and KL would be skew. They are in different planes and they are not intersecting. There's not a symbol for skew, so you'll just say NS and KL and make sure you're putting the little line segments above them. All right, a pair of perpendicular segments. Somebody different besides Jacob or Jackson. RM and LM, is that what you said? Okay, they look like they're forming a right angle, but it's not marked that they're forming a right angle. Can you pick a pair that we can be guaranteed are definitely forming a right angle? RM and SR, very good. So notice the little right angle box there. Just to make sure that they really are. And again, your perpendicular symbol is upside down capital T. So RM is perpendicular to SR. All right, and lastly, a pair of parallel planes, somebody different than those three. Go for it, Carlos. NMR, so don't forget the word plane in front. Plane NMR would be the front left plane here. And what did you say the other plane was? Very good. And the little parallel symbols straight up and down, and then plane KLQ. So again, 3 letters. Use the word plane in front, and then use your parallel or perpendicular symbols. Any questions? Okay, you and your partner try the next ones, and then we'll check our answers. And we'll be done. Okay, let's check and see how you're doing. Ronnie, can you give me a pair of parallel segments? BE and FJ. Very good, and make sure that you used your parallel symbol and that you have line segments above them. Again, I would warn you on the homework, watch your words. Are you talking about parallel segments or parallel lines? If it's lines, make sure you put arrows. If it's segments, make sure you do not. Okay, let's go with Tori. Can you give me a pair of skew segments? Okay, EF is not actually in our picture. That would be this line segment here. Can you name some that are in the actual picture that are drawn? BF and CD, very good. Is that what you said? I'm sorry. I thought you said EF. BF and CD. Good job. BF and CD. Another pair of perpendicular segments, Haley. BF and FG, and that is true. Again, it's not actually marked though. If we're looking at BF and FG, the right angle would be actually back here going to this dotted line. Okay, so if you look at the little red angle mark, it's actually showing BF and FJ, right? Are you saying J or G? Sorry. Are you with me? Does this make sense, though? Your answer is true, BF and FG, if that's what you said. Maybe I heard you wrong. Okay, FJ, sorry. Yes, BF and FJ is correct. I can't hear today, obviously. BF is perpendicular to FJ. And then parallel planes, let's go with Jack. Oops. I don't know. Doesn't want to write for me. Awesome. And plane, I'm sorry, can you repeat the last one? Thank you, CGH. So plane BFJ would be the front and CGH would be the back. Very good. Any questions today? All right, I hope you feel